So the question is stating a ball is dropped from a height of 90 meter on a floor. At each collision with the floor, the ball loses 1/10 of its speed. Plot the speed time graph of its motion between t equals 0 to t equals 12 seconds. So now we are going to discuss till 12 seconds, and every time the ball is bouncing, the ball loses 1/10 of its speed. And we are worried about the speed time graph, so we are not worried about the directional aspect. We only have to consider the speed. So now we begin the question in this fashion. So the ball is dropped from a height of 90 meter. So if we take downward as negative, which I always do, so I take s equals minus 90 meter. And since the ball is dropped, so I take the initial velocity or the speed as 0. And the g is acting in the downward direction, so I am taking acceleration in the downward direction minus 9.8 meter per second square. So we are first of all calculating the first time when the ball is going to hit the ground. So we apply s equals ut plus half at square. So we solve it as minus 90 equals 0 minus half into 9.8 t square. From here we obtain t equals 4.28 second. So now we can say that at t equals 4.28 second, the ball is going to hit the ground, and it is going to hit the ground with a velocity v equals u minus 9.8 into time t, which is 4.2 second. So we get the velocity which is equal to approximately 42 meter per second with a negative sign. The negative sign is implying that the ball is moving in the downward direction. And over here we put another aspect, the velocity of bouncing back. So the question is saying that it is bouncing back with after losing 1/10 of its speed. So I can say with the 90% of the speed. So we are doing 0.9 v and we calculate it to be 37.8 meter per second. So till this aspect, if we talk about the motion of the ball, so the ball have fallen freely from the point of 90 meter mark and it strikes the ground over here at t equals 4.2 second, and after striking at 4.2 second, it is rebouncing back with a speed of 37.8 meter per second. So now we are thinking in this way. So it is bouncing back with 37.84 meter per second, and now we are calculating the time when it is again going to hit the ground. So if it is again going to hit the ground, it will reach a certain maximum height and it will again hit the ground. So I can take it in this way, that initial velocity as plus 37.8 meter per second, and the displacement is going to be 0 because it is again going to hit the ground, and a as minus 9.8 meter per second square. So if we put the equation for this part of the graph, so I say ut plus half at square, and if we solve this out, s equals 0 8t minus half 9.8 t square. So from here we obtain t equals that is 7.71 second. So 7.71 second after making the first impact. So from here we are ready to draw our speed time graph, which the question is asking us to do. So it is again going to make an impact at 7.71 second and lose 10% of its speed. So if we draw this particular graph, we can draw it in this way. So this is the speed time graph we are talking about. So the ball is going to go attain a certain speed, a maximum speed of approximately around 42 meter per second. And this is going to take place roughly around 4 seconds. So I'm putting over here roughly 4 seconds. And the speed is going to drastically decrease, and we got the decreased speed as 37.8. So the speed is going to come down at 37.8 meter per second at approximately 4.28 second, which is this part. And after this point, it is going to rebound back to a certain height where its speed will become 0, and after reaching that height it will again come down to hit the ground again with the same speed. And this complete duration took place in a time duration of 7.71 second. So we can add 7.71 plus 4, that is 11.71 second. So over here at this point, the ball again makes the impact with the ground and loses 10% of its speed, again. So if we lose 10% of this speed, we can calculate the next speed as 37.8 times 0.9, which is equals to 34.02. So just after making the impact, the speed is going to drop almost instantly to 34.02 meter per second. And again the speed will start changing. So since the question is asking us to draw it till 12 seconds, so we are restricting our graph till here. So I hope the motion is clear. I am again explaining the motion. So while coming down, the speed went on increasing. So the speed went on increasing till it came down, and after making the impact with the ground, the speed was 37.8 meter per second. Now this time the ball, this time over here the red part was the 90 meter to the ground, and after this at 4 seconds it hits the ground, and then it is rising up with the speed of 37.8 meter per second. It reaches a certain height and again falls to the ground. So this duration is this part where it is 11.7 seconds, and then it again impacts with the ground and rises back with a speed of 34.02 meter per second. And again its speed will go on decreasing till it again reaches the highest point, and again it will come back to the ground and again loses 10% of its speed. So since the question is asking us to restrict ourselves to 12 seconds, so we are restricting ourselves to 12 seconds, and this is how the nature of the graph is going to look like. So with this we have completed the discussion of questions for the motion in one dimension, and we have also discussed the graphical aspect for the motion in one dimension part of kinematics.